And our next speaker is Mr. Deepak Mukunthu. Mr. Deepak Mukunthu is a Senior Director of Product for the Agent Force AI platform at Salesforce, leading agent quality, testing, benchmarking, and monitoring capabilities. With over 2 decades of experience in AI, machine learning, and big data platforms, he has held key leadership roles driving innovation. A published O'Reilly author of practical automated machine learning on Azure. Deepak actively shares insights of AI product management and technical product leadership across various platforms. Please join me in welcoming our speaker, Mr. Deepak Mukuntu.
Thank you. Thanks, Kavya. Can you guys hear me well?
Mr.
Kavya, can you
Deepak,
confirm if you can hear me well?
yes, I can hear you.
Okay, great.
Yeah,
Any
can you
ending my
please
deal?
share your screen?
Yep, I am going to share my screen right now.
Yeah, thank you.
Um, Desktop 2, okay. Can you see my screen now with the deck?
Yes, I can see your screen.
Great. Okay, let me go full screen and then we will get started.
Okay.
Okay, thank you. Thank you all for this opportunity. Nice to meet you all. I lead product management at Agentforce AI platform at Salesforce, and today we're going to talk about how to build and manage AI agents for real-world use cases. With that, quick precursor on what are AI agents, right? AI agents are basically autonomous or semi-autonomous systems that perform tasks using perception, reasoning, and action. I'll talk about all these three in the next couple of seconds, right? Perception is understanding what's happening around that system. Reasoning is perceiving is like getting to know what's going on. These are like sensors and signals captured on what's happening. And then reasoning basically is like understanding all of those signals and making sense of them and then acting. Right. So at a very high level, this is what we humans do, which is we look at things, we smell things, we touch things. Perception is that, right? And then we try to understand, make sense of like what's going on. Like when if I see something, if I see a child crossing a road, I'll understand that, okay, there's a kid crossing the road. So now for me, it's about safety immediately, right? So that's where reasoning comes in. And then action is like, I'll go and see if I can help that kid cross the road safely. Action. So agents are no different than humans. And basically, AI is evolving into a state where a lot of what we do as humans could be automated, which is where some of the key characteristics of agents come in. Autonomy. Autonomy is these systems operate with minimal human intervention or supervision. Intelligence, like I talked about, they can solve problems, they can learn. They don't need to be explicitly instructed like our traditional software where you have to program. You have to say exactly for this use case, this scenario, do this. For if we all have done through software. I've done software engineering where we have written programs, codes, designed things which are very deterministic. In this new world, they are all non-deterministic systems. They can learn from what's happening. Adaptability is like changes as the system changes, as their environment change. These systems can learn and then adapt, which is very important. To be an autonomous system, you need to be able to learn and adapt. And then they're not doing random things. They're goal oriented, so you can actually set specific goals and then have them figure out exactly how to meet those goals. So very high level, this is what a typical definition of an AI agent is. They they can autonomously operate. They can intelligently understand and take action. They can change and learn as situation changes. And then they're all target oriented or goal oriented, right? So one of the key questions I keep getting asked whenever I talk about agents and is what happens to humans and what happens to our future, right? Will all of our work be replaced by agents? The answer is no. Agents are not here to replace our jobs. Agents are here to help us. Agents are here to collaborate with us to make our life easier. So you're already seeing, we are all seeing this trend where a lot of automation is now being done through agents or being envisioned to be done through agents. So I do envision the world to be more humans and AI agents will collaborate to get tasks done more efficiently, and hopefully we will be able to get things done that we have not been able to so far with some of these AI advancements. With that, real world use cases, I touched upon this briefly. Here are five broad categories that I believe will be like top of mind. Already a lot of progress is being made in these areas around how AI agents can help accelerate accelerate progress. Customer service, right? This is the first one, chatbots. Chatbots have existed for long, but today's chatbots are not human-like. They are very programmatic. They're very programmed, which means that they can't answer questions that they're not programmed to answer, right? So with AI agents, customer service is going to be disrupted. We are already seeing a lot of disruption here. Advanced support agent handling, right? So agents are can handle 70 to 80% of what human agents can do. AI agents can do that today, which means that your support staff can be a lot more efficient because 70 to 80% of questions can be handled by these AI agents. Healthcare is the next big one, right? This is where a lot of diagnostic assistance can be done, patient monitoring can be done through this automation. Again, right? This will all be supporting healthcare professionals so that healthcare professional can be more efficient. Finance, fraud detection, we all know this is a big area, huge industry. And the other one is stock and portfolio management. A lot of those things are also things that you can program to a large extent. We have seen a lot of people investing in this space, a lot of companies investing in this space in the past. With AI agents, I believe that this space is going to evolve significantly because these agents can learn. Manufacturing, predictive maintenance, we all have seen AI used in predictive maintenance. I believe that area is going to also be significantly helpful with AI agents coming into picture. Software development, this is where you're seeing a lot of new coding tools, vibe coding, those patterns emerging. That's because now we have this technology which can help us start from blank slate. You can just have like a couple of instructions to say, oh, right, I want to create an application like this. And then it'll go ahead, the system can go ahead and generate full code for that application. And then you can also tweak things, right? If you already have a program written for an application or you have a full end-to-end stack for an application, you can ask an agent or a system, AI system, to go and debug things, to go and test it. So a lot of investment is happening in this space. We have seen like GitHub Copilots emerging, vibe coding tools like Cursor. I don't know how many of you have used. If you haven't, please do try. It's amazing how human-like these softwares are emerging. With that um, comes like, what does it take to build these agents, right? So I talk about this in four stages usually, and if you look at these four stages, there is nothing unique about agent development here. This is like typical software development, right? You start with defining a purpose. Why do you want to build this agent? What problem are you trying to solve? So clearly articulate your use case and then your business objectives. Next is build and test. You architect your system, you figure out like what should in a typical software world, you talk about like, oh, what should my database layer look like, what should my middle tier layer look like, what should my application layer look like, and what should my user experience look like. So that's what you typically design, and then you go and build and test those using a good set of rich test cases. AI agent development is no different, except that there is a lot of non-determinism, and we will talk about some of the next steps here. But one of the key things to keep in mind as you build agents, as you build any of these new AI-powered experiences, is how do you measure quality? As you can see, like if you are interacting with ChatGPT or any of these AI products, you ask it one question, you'll get an answer. You ask it the same question again, you will get a slightly different yet still correct answer, which means that you cannot test these agents using a deterministic approach. You have to figure out ways to verify the non-determinism. Right? There are a lot of interesting patterns emerging here around LLM as a judge. I don't know if you've seen, you can use LLMs to judge work of another LLM. You can use LLMs to judge whether an agent is doing good or not. You can use an agent, you can build an agent to test your agent. So a lot of meta patterns are emerging here, but that's important to keep in mind as you're building agents, that this is not a deterministic system, which means that your approach to testing for quality, testing for completeness, testing for even monitoring needs to have a lot of non-deterministic aspects to it. The third step after build and test is deploy. So you need to make sure that you have a good deployment strategy, wherein you are, and again, this is nothing new. You need to have a good rollout strategy, starting from doing some internal testing, some dog fooding, small alpha user testing, beta user testing, and then when you go to production, also have some approaches around gradual rollout, A/B testing, and then more importantly, have feedback loops, have enough instrumentation, have enough feedback collection mechanism with your users so that you get the feedback. And these systems are, we talked about it in the beginning, these systems are learning systems. So they can learn if we can provide them feedback. So feedback loop is important, like any other software, but in this world, this is a lot more important because the system itself can learn. The last one is monitoring and improvement. This is where you talk about make sure that you have good performance metrics. And with the feedback loop, you have a way to iterate. You can fine tune your instructions. You can fine tune your prompts if you're building an LLM-based application to make sure that you have a good way of monitoring and improving your system. Okay, with that, we'll dig deeper on each one of these aspects to the next level of detail. Define purpose, right? Again, like I said, this should not be anything new. If you have already been in the software industry, this is the first step of any project, any product you build. You start with purpose. You start with what is the business problem you're trying to solve. Do not start with technology. I'm seeing a lot more of this emerging as a problem in the AI space now because LLMs have revolutionized everything we do. So most teams, most companies, most organizations start with technology. They start with, oh, we have this great AI. What can I do with it? Yes, that is a good high level problem statement, but do not, when you get to the next level of details on like what should I build, don't start with, oh, I have this technology. Let me try to wrap this around something to do blah. Right? Start with what is the problem you want to solve? Where are your customers struggling? What is the big investment area for you that you think will be the next big thing for you as a business, as a company, as a team? Then work backwards from that business problem and then figure out what the right technology solution should be. How do I use AI for doing that? So that should be a second question, not the first question. Identify tasks that are best suited for automation. So when you try to define your problem, whether to use AI or not, how much to use AI or not, should be based on how much of that can be automated. How much of that can be done in a repeated fashion is what you should look at when you look at picking up what AI investment will be helpful. Then, like typical investment, any investment have clear KPIs and success metrics. I've seen a lot of teams and organizations struggle with this now, especially in the AI world, because AI is not free. These large language models and huge investments around that ecosystem does cost a lot of money. So make sure that you're very clear on what is the goal, what are the KPIs that you're trying to measure, what does success look like, and then as part of success, you can also make sure that you have some sort of ROI built into that success measurement. Stakeholder expectations and requirements are the next things you need to make sure that once you have your goals, then you figure out like who are the users and what do they need and how do you make sure that your investments are meeting their requirements. And then always balance technical feasibility with business value. This is very, very important. Um, Again, there are a lot of interesting technical advancements that we're going through, but make sure that you balance those with the business value. So overall, if I were to summarize this slide, it's about start with business problem, start with customer problem, do not start with technology, and then have a good balance of technology and business value, and then have the right KPIs and measurements to be able to measure that on an ongoing basis. Next is build and test. So these AI systems, I think I talked about a typical software stack where you start from what should my database technology be? What should my middle tier technology be? What should my application layer look like? What should my user experience look like? With AI, The four key components or the five key components you can think of are: first is, once you have defined what problem you want to solve, these are the four. The first four are critical pieces. One is, what is the foundation model? What LLM do I want to use? Again, like, don't stick to one LLM, but as you start building your system, you start with what is the most apt model that you think is good for this use case. Again, this should be based on what capabilities you want to your use case needs. Um, what are your latency requirements? Not only functional requirements, but also latency and cost requirements also become important here, because models come in various sizes with various different capabilities. So you need to figure out what model is best for your use case. Then comes, once you have the model knows something. The model has been pre-trained with huge volumes of information, but still it doesn't know your specifics. Your organization may have your own specific information, your own specific data that's sitting in various data sources, maybe Snowflake, maybe some databases, both structured and unstructured data. How do you bring those into your design so that your model not only knows what it is trained on, but also can use your information? This is where the second piece comes in, which is retrieval systems. RAG, if you have heard, retrieval augmented generation. It's all about how do we bring the knowledge that we have, like our organization has, to this system so that the large language models can not only have their knowledge, but also can use your knowledge. Third one is around planning component. This is where um, I would, in my first slide, I talked about these systems can learn and can act on. So for it to learn and act on, you need to help it break down the task into smaller tasks. A lot of these LLMs today can do it. Like if you go to Claude and ask it a complex question, the model itself will break it down, and you can ask it, you can prompt it to say that, can you describe your thought process? It will actually go and describe you, like, I'm breaking this problem into n different steps, and this is how I'm going to approach step number one, this is how I'm going to approach step number two. So the LLMs are becoming more and more powerful. They can think, they can reason out, but in a business use case, or in a use case that you want to completely control, have a good control on, you need to guide it, which is where these planning components come in, where you can break down your task, and then you can have a good decision making model. So that's something that should be part of your architecture. And the fourth one is tool usage, right? LLMs can do a lot of things, but they need to have access to data, which we talked about the retrieval system bullet point. But they also need to have access to various APIs and various tools that can act on. For example, if you have a simple agent which sends email out, or which sends a message out to your users, you need to have whatever that component is that sends email out, that you may already have built as part of your application or your software. You will need to make sure that this system, this new AI system you're building or AI agent you're building, has access to those tools, so that it can use your tools to reach out to your users. Right? So that's where tool use comes in. So these are the four broad pieces of the AI architecture as you're building agents. But then comes two other important aspects, right? One is safety. Safety mechanisms need to be in place. These LLMs and any generative AI products, they are very powerful, they are very innovative, they can reason out and take action, but you also need to make sure that they have the right guardrails, they have the right human oversight, so that if things go wrong, that you can correct. But then first step is even checking, even making sure that things are going on track. So guardrails becomes an important aspect here, and there are a lot of great progress being made here around how do you establish guardrails as you build your agents. You can have guardrails around, oh, I gave this agent these instructions to follow. Is the agent really following instructions? You can do that today. You can actually use another LLM to do that. Think of it this way: there's an LLM that can do guardrail check for you. You can send it all the instructions you gave to the agent, and then at runtime, when the agent acts on individual tasks, this guardrail LLM can actually monitor the main agent, and tag whenever things are not being followed. So that's where we are. Right? That's slightly meta, but a lot of LLM based safety checks are emerging as key trend here. So make sure that you use these approaches when you build your agents. And the last but not least, testing. I talked about it briefly. We need to make sure that because these agents are not deterministic, our testing approach should also be a combination of deterministic checks and non-deterministic evals. Deterministic checks are things like, um, this is the output I'm expecting. When I give input A, the output should be B. You can check that deterministically. You can check that is the actual output same as the expected output, in this case B. Non-deterministic evals are things like, I expect the response of my agent to have a summary of this conversation. Note that here we are not saying the expected response is here is this is the summary of conversation. No, because we you don't know what the exact summary should be. So you need to have a non-deterministic way where you can actually specify and use an LLM as a judge to judge whether the input, whether the expectation that you have, you can describe in natural language, you can describe in English, and then that judge will take that as expectation and then map it to the actual and then say if it's yes or no, if it's pass or fail. I know it's a little meta, but this is where we are going. The industry is heading towards making sure that we can use LLMs and generative AI and other agents to test and verify the agent you're building. The next one is deploy strategically. This is where things like test rollout. Right? How do you test, learn, scale? Sorry, was there a question? Okay, I'll keep going. Test, learn, and scale. This loop is something you have to optimize for, um, and it's all start small. And this is something that I tell everybody who is building agents or AI systems is don't try to design the whole thing completely because you're not going to be right anyway. Start small. Start with a one use case, just couple of flows, and then define that, test it, ship it. We are in this world where while quality is important, speed is also important. Like if you're not moving fast, then you are going to get outdated. So make sure that you can have small MVPs, ship it, learn from it. That has been a mantra for very long time now, but then it becomes even more important in this new era. So make sure that you have a good rollout approach. Human in the loop is also important. Like you make sure that as you have your MVPs, don't go fully autonomous. Have human in the loop. Humans can look at the response, can look at agent actions, and then maybe correct the agent or guide the agent. So start with that, and then slowly, gradually move towards like semi-autonomous systems where only if automation says something may be wrong, then have humans look at it. So have that kind of gradual step-by-step human in the loop transition planning. Right? And then user training and change man, this is huge. Users are also going through a huge learning curve here. Users meaning your customers who will be using these AI powered systems. They also need to be educated around what does typical good response look like. What should they do if an agent's response is incorrect? So all of users need to be trained on like ability to give feedback. So give feedback. Make sure that if you see something wrong, give feedback, and then the system will learn and improve. So that mindset, it's not just the builders or people who are building these agents need to have that mindset. Users also need to get into their mindset, and that I think is happening already, but a lot more to be done here. Make sure that your user interface brings these kind of aspects to your users. Supervision and oversight is also important. So this is where like some of the feedback loops we talked about. So feedback collection and supervision. So you collect enough feedback so that you can supervise, you as a builder can supervise. And then there is also interesting trends here around how do you use other agents to supervise your agents. So first step where we are bringing agents into is doing a specific task. Now there are discussions and there are trends emerging where you can have supervisor agents who can supervise other agents, and then by supervising other agents, what I mean is performance managing them, looking at are the agents doing well, are the agent getting enough traffic, are they responding well, what are the quality of the response of the agents, what is the latency of those responses, cost wise, how is that agent doing. So all of those are interesting aspects of measuring whether the agent is doing well. And we are seeing a pattern where even that supervision is being envisioned to be done by other agents. So supervisor agents, if you have heard, is where we are moving for this area. Okay, monitoring and improvement. I think I briefly touched upon this. Performance dashboards and analytics, again, very important like any other product, more so important in AI because these are autonomous and semi-autonomous systems. User satisfaction and experience metrics, again, thumbs up, thumbs down, is a good way of capturing user satisfaction. Also, implicit feedback, like did the user do what you were expecting them to do when the agent provided them some information? So those are implicit signals. If you can capture that, you can measure user satisfaction. Error analysis and root cause, again, like tracing is an important concept. Session tracing or the tracing of the full end-to-end session between the agent and the user is important because that way you can have the rich information for you to go troubleshoot. If you think the user is unhappy, then you have the log of exactly what happened. Again, a lot of this is not new. A lot of this is existing investments. It's just that some of these things are becoming a lot more important in the case of AI and AI agents because these are autonomous and semi-autonomous systems. And these are non-deterministic systems that you're not coding explicitly for. Model drift detection is critical as well. Regular retraining and capability expansion. This is very, very important. It's not just measuring performance and learning from it. It is also like how do you take that learning and retrain? How do you improve your prompt if you're an LLM-based system? How do you improve your prompt? How do you improve your instructions, your agent instructions? And how do you improve your models? How do you fine-tune your models for your specific needs? This is super, super important final step in the monitor improve step. Okay, so I think this slide talks about real world challenges, hallucinations in quality, latency and cost, regulatory constraints, adoption resistance, user adoption resistance. I don't want to take more time. I know I'm hitting my time here, but we touched upon these four aspects in the four stages that we went through. For hallucinations quality, have robust testing tooling, testing approaches in diverse scenarios, and have right guardrails. Right? Latency and cost, this should be done mostly through initial planning and through continuous monitoring and optimization. Regulatory constraints and privacy constraints, how do you make sure that your agents are following regulatory restrictions? You need to explore like privacy preserving techniques. There are a lot of techniques that were already there before the LLM era. A lot of those are relevant still. And then the data handling, make it as transparent as possible, give users control as much as we can. Adoption resistance is an interesting one. This is where I talked about as you design your user experience, co-design it with your end user. Like show them what you're trying to build, get their feedback. That way they're not surprised because these systems are different than our traditional systems. And then clear value. Also, as you engage with those users early in the life cycle, show them the value, tell them why it's important, and then see if they have unique point of view that you want to accommodate. Okay, so I think this is the last slide almost. Agents are powerful. They are not magic, right? You need to start with a clear business purpose and very well-defined steps to get to the business purpose. Follow your engineering rigor. This is like any other engineering problem you've solved in the past. This is the same. You need to have a rigor, build iteratively with feedback loop, and that you can monitor and improve continuously. Focus on user value and reliability. This goes back to the clear business purpose, but I want to reinforce it. Focus on user value. Don't start with technology. Don't focus on just technology value. Build organization capabilities alongside technical users. This is important. This is super important. We talked about a lot of technology and how you think of technology so far, but it's also mindset, right? Make sure that your organization is geared to taking this mindset, right? I'm seeing this like everywhere in our organization, in many other organizations. Typically, people feel like, oh, I cannot ship this because there's no quality. I need to make sure that this is tested completely, thoroughly with like hundreds of test cases, thousands of things, and only then I can expose it to my users. No, that thinking has to change. That thinking really has to change. You need to make sure that you can start small, ship small things, learn from your users. A lot more important now than before. And then the other one is. The space is evolving super super fast. Like every day I see something new coming up. Every week a new model was being released. Every week new paradigms are coming up, right? Now there's this agent to agent protocols coming up where we can how do we make different agents interact with each other? MCP, if you've seen, is a way for us to like have different tool connectivity. Like how do you bring standards to it? So this is not end of the world. This is not done. This is still changing. This is still evolving. So the key to success is stay flexible and keep learning. Have that learning mindset. With that, I think I am done. Questions?
Wonderful and great inspiration to be courageous and to put your product on the market right away. That's well done. Anybody have any questions? It was a very beautiful presentation. Congratulations. And let's see again if they want to ask you
Thank you.
questions, our colleagues. So what if the product that you have, once the customer says, I cannot use it, it's too hard. What do? You refund the customer?
Sorry, what
What
product are we
should you,
talking about?
if your client refuse your product, rejects your product, what you gonna do?
I think see, this is where you should not reach that stage, because if you built it right, if you engaged with your users from day one, you would build the right product. You would build the right product for your users, right? What you're asking about is a situation where I would think you should not even get to, because by the time you get to a stage where you say, "Oh, my users are not liking my product," means that you have lost the battle already. And that's how I think of it.
Do you think, answer please, between statistical interference and AI, what is the difference? Why is AI different than statistics?
Statistics is so I think it's an interesting question. The reason I'm thinking so much is AI has also evolved
Like
in the
what?
last, right? AI has also evolved. Say, initial AIs, if you look at it, were statistical models. Like initially, when people started talking about, oh, I want to do anomaly detection, I want to do like prediction, logical regression, logistic regression, all of those were based on statistics, right? Those are the foundations. So I would not say statistics is very different from AI. Initial versions of AI were very close to statistics because they were built on that, like numeric analysis and stuff like that. The most recent trend that we are into in AI is lot more than statistics. It's a lot more of like a pattern matching from your data. So that's what I would say is different. Like statistics is pretty deterministic, while where we are right now is very, very non-deterministic because it's starting from pattern, looking from patterns. So unstructured data and pattern matching is very different than structured data and statistical analysis. So that's how I would look at it.
Looking for buttons?
Say that again. Sorry.
Backen matches, you said?
Pattern,
Looking for
pattern matching, pattern
patterns.
matching.
Patterns. So that's the difference.
Yes,
Looking for
yes.
patterns
So
and statistics.
so I would say statistical analysis is for structured data and doing deterministic analysis, while the AI that we are in right now, the AI trend we are in right now is unstructured data and pattern matching.
Pattern matching.
Yeah. So
And from
think
that,
think of it this way. Another way of looking at this is how do humans operate, right? You don't you don't operate always in a structure. You don't know that you can be thrown any information, right? Any new situation, how do you react to it? You're not coded to react to all situations, right? You still are able to figure out something from that new situation. That is where we are going in AI. Right? Previous versions of AI was not that. Previous versions of AI was there's a table of information. There are four columns of data. Now you need to predict a fifth column using these four columns, right? That's very structured. Now we are saying, oh, there are these n different images. Now, can you figure out what is in the image? This was deep learning. Now it's like a lot more deeper than that with LLMs is how I look at it. Lot more unstructured data and pattern matching.
pattern matching.
Yep.
Do you apply for grants? Have you applied for grants?
I haven't applied for grants.
No. Pattern matching.
I,
So this LSM, did you create it yourself? Did you invented it?
So sorry, I think
The product. Did you invent the product?
maybe I should clarify, right? I did not do a product pitch today, right? My approach was I just shared how to think of AI, how do you build AI. In this case, my company is building a platform for others to build agents on top of, right? So it's not my individual thing. I'm here just to share my knowledge on what I'm seeing from customers and organizations as they're adopting AI. What are some challenges? How to build AI products in this new world. That's what I wanted to share with this group.
Somebody had a question for you. Who's that? Please unmute yourself.
hello.
Hi.
Yeah, hi. This is Terrence. I have a question. I mean, thanks for your sharing, by the way. I was telling Sunny that, some of the insights that you shared were really, really valuable. I'm gonna make this available to my team. I have a question about how small startups without the resource capacity of Salesforce might go about implementing some of the suggestions that you've mentioned here. And I understand this question is probably very wide ranging, right?
No,
But if you
it's
were
a
to
great
advise a
question.
smaller startup, yeah, what do you what do you
It's a
think?
really great question, right? And I think it's a lot more now than before. Small teams and small companies, small individuals can also easily get into AI, right? You don't need a huge investment around like a big platform or whatever. I would say if you have not already started, try Cursor, try Replit. These are vibe coding tools that can actually help you build a full end-to-end working prototype in a minute, in few minutes or hours. And I've tried it and I'm really amazed. Right? You don't need to have full stack engineers building the system and whatnot, right? Just start with it. And you'll be amazed to see like how amazing the output is within minutes. And then the beauty of at least Replit that I tried with for a few examples is it not only builds the first prototype in minutes, it also you can actually play around with the prototype and say, oh, this is not working. And then it'll go and look at the code and it'll tweak the code and it'll fix the code for that use case. So it's so interactive, so amazing that I feel like you don't need army of people. You don't need a big team. You can actually start very small, get the prototype out, get your users to validate that, and then if you think that there's enough there, then go and build. So that's what I would say as a easy to get started advice.
Thank you, doctor. You're an inspiration, and please teach me some more. I left your message. Please
Thank you.
teach me more, please. And we look forward to see you at the next lecture. Can you come tomorrow to the panel discussion?
When is that? I don't think I have it on my.
5 o'clock, UK time.
Um, I will confirm. I think I'll confirm through Kiran. I think I'm working with Kiran.
Yes,
I
please,
can
but
confirm.
because I personally want to invite your expertise to
Sure.
respond to the questions from Professor Richard Nielsen. And we have to defend AI. And please come, it's important. Yes?
Okay, I will confirm.
Okay.